Hello everyone, this is going to be just a number of problems that are done using tape diagrams as extra examples in using the whole, when the whole information is given, the part of one of the two parts in a part-to-part ratio is given, or the more extra info is given. This is related to, or it starts in lesson 5-6 and it continues on from there, but this is mostly taking place directly after lesson 5 or in lesson 5. So let's get started. The first problem says there are 5 onions for every 10 potatoes. If there are 200 potatoes, how many onions would there be? So the first thing you can do is make your little tape diagram. So that would be, we have 5 onions. So onions, 1, 2, 4, 5. And potatoes, so 1, 2, 3, 4, 5. So there is our 5 to 10 ratio for the 5 onions for every 10 potatoes. Then it says if there are 200 potatoes, how many onions would there be? So this is, it says if there are 200 potatoes right here. And so this is, they're telling us how many there are right here. 200 potatoes. This would be 200 potatoes. They're giving us one of the parts. This is a part problem. So a part is when, if we were given, since this is a part to a part ratio, so a part is if you're given one of these kind of rows, really, or one of the whole pieces, individual pieces. The whole would be if it was the whole thing. The extra types of problems are if it's just this extra bit. But this is a part because it's telling us how many the total potatoes there are. So what we have here is we have 200 potatoes. So this is 200 divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Divided by 10, which is 20. So we know that there are 20 in all of these 20, or these all represent 20. So these all represent 20 as well. And then we can use that to figure out that. How many onions would there be? And we could say that there would be, there are, seems terrible on a tablet, but there are 200, sorry, not 200, there are 100 onions. Even though I have this atrocious handwriting on this tablet, I'm writing it as a sentence because that is how we want our answers to be given, as sentences. So the next one, Mr. Doyle went on a backpacking trip. For every 8 miles he went uphill, he went downhill 6 miles. So that's a ratio right there. So we have every 8 miles uphill, so we have uphill, we can do 8. Some people like to use circles, some people like to use squares, it doesn't really matter. For every downhill 6 miles, so downhill we'd have 6. 1, 2, 4, 5, 6. Okay, so there's our ratio, 8 to 6. And if I went uphill for 20 miles more on his trip, how many miles did he or I go downhill? So this is a more or extra problem because they're saying we have 20 miles more. So if you're looking at this tape diagram, what represents more? Well, we know that the uphill has obviously more. It's a bigger piece. But the actual part of the diagram that demonstrates that this is more are these two here, these extra two at the end. So these two right here are the more. So those two pieces are the 20 miles. So it's 20 divided by 2 and 10. So both of these would have to be 10 in order for them together to be 20. So then these are all 10, everything's 10. And for time's sake, I will just omit writing sentences after this, even though we do want on work their answers to be sentences, and this would be 60 miles downhill. Next one, Jane has a total of 200 pieces of clothing. If she has 3 pair of pants for every 7 shirts, how many pairs of shirts, or that should just say how many shirts does she have? So she has 3 pairs of pants for every 7 shirts. So we have pants, we have 3. Here's another way you can draw these, just like that. Instead of separate boxes, just clump them together. And for 7 shirts, oops, should be shirts. 1, 2, 3, 4, 5, 6, 7. Okay, so 3, 2, 7. And then it says a total of 200 pieces of clothing. So what is the total amount of clothing? Well, the total amount of clothing would be the pants and the shirts. So all of this is all 200. So we have 200 total items of clothing, and we're going to divide that by, we have the 3 and the 7, so that would be divided by 10, which gives us 20. So there's 20 in each of these, every single one. So it wants to know how many shirts does she have. She would have, let's see, it would be 20 times 1, 2, 3, 4, 5, 6, 7. So 20 times 7 would be 140. So 140 shirts. And we also know that that is, then means she has 60 pants. A lot of clothes. Next one. At a recent race, for every 6 people that ran a 10K race, 14 people ran a 5K race. So our ratio is going to be 6 to 14. So we have the 10K would be 6. 1, 2, 3, 4, 5, 6. And the 5K is 14. All right. And then it says if 200 people ran a 10K race, sorry, if 120 people ran a 10K race, how many people ran the 5K? So 120 people ran the 10K. This is how many people ran the 10K. So we have 120 people right here. And we need to divide that up into the 1, 2, 3, 4, 5, 6 groups. So divided by 6. And that's going to be 20. 20 in each. Then 20 in all of these as well. I'm not going to write them in all of them, but so it wants to know how many people ran the 5K. So what we have here is we have a 5K times, and there are 14 of these. So that would be 20 times 14. So 14 times 2 is 28. So with a 0, 280. So that would be 280 people for the 5K race. Okay, and actually before I move on, that was a part problem, right? Because they told us the part. They told us this whole 10K part. I think I skipped that on the last one too. Yeah, I did. This one was a whole problem. That last one was a whole problem because they gave us the whole entire, they gave us all the pieces of clothing in that last one. So, at a local grocery store, a customer purchased 8 bottles of water for every 7 protein bars. So we have water bottles, we have protein bars, and we have 8 water bottles. For 7 protein bars. Okay. And if the customer purchased a total of 30 items, how many bottles of water and protein bars did they buy? This is a whole problem because it said purchased a total of 30 items. So the total items would be the water and the protein bars. And we have 30 items. Like it tells us in the problem. And we have, in here we have the 8 and the 7 different groups. So we're dividing that up into 15 groups, which would give us 2 in each part. 2 in every single one of these, and so on. So we would have 2 times 8 water, so there would be 18 water, and 14, oh sorry, 18, 16, that's bad multiplication there. 2 times 8 is 16, so 16 bottles of water and 14 protein bars. And finally, the ratio of respectful, quiet students to loud, disruptive students in the hall is 12:4. If there are 16 more respectful students than disruptive students, how many disruptive students are there? Well, there's some typos in here, but we have 12:4, so that would be respectful to disruptive. So 12 to 4. If there are 16 more respectful students, so the respectful, this is a more problem because it says 16 more. So these represent the more. There are 8 more pieces of the respectful. So that would be when we have 16 students divided by those 8 sections equals 2 per section. So these all have 2's in them. So you can find out that there would be 8 disruptive students. All right. Hopefully those were helpful examples.